Okay, guys, I'm sorry about that, but the video, whenever it goes over 33 minutes, it cuts off and starts a new one. But unbeknownst to me, I had some other videos on here and it didn't have enough room, so the rest of the problem didn't take. So I have to redo it from this point. Sorry. Okay, so anyway, we've got our data chart filled in. Just don't look at that right there for a minute because there's some things on there you don't need to see. Well, I'll tell you what. Let me just hang on just a second. Hang on. Don't look. Don't look. You don't see this. You don't see this. You don't see this. Okay? You don't see this. Hang on. All right. There. That's better. All right. So I found out 200 meters divided by 2.85 seconds is 70.2 meters per second, and I put it over here on the chart. Now we need the other component because we can't find the resultant final velocity until we have both components. So how are we going to do it? Well, remember, we're going to use the general equation, and we even talked about it right up here. But guys, don't start with this. This will kill you on the AP exam if you try to do this. They want to see where you're getting stuff from, okay? So you always start with your base formula and then show how you derived what you're going to use. If you start with this, you're going to lose points because they don't see this. They don't see what you did. And they want to see what you did. That's the whole point, showing that you know, not just that you memorized a formula for a special case, but that you know how to derive what you need. So I cannot stress enough. We're going to start with that. Okay? Now we know it starts on the ground, it ends on the ground. So there's no displacement. But we do have an initial vertical velocity for the hang time and an acceleration. So we just do the algebra just like we did above until we've got our expression that we're going to use. All right? So plug in your values. We get 1/2 times 9.8. Now remember, why is the negative not on there? Because when we take this to the other side, one of the two has to be negative. They're both positive on this side, so one has to be negative. I put it there, so now negative times a negative, you end up with a positive. That's where the negative went, okay? Here, I'll move it over a little bit. Negative times a negative, you get a positive. So that's why I didn't put it in there. Now, when you do this, you get a value of 14 meters per second, if you'll check your calculator. And I put that, or we are going to put that right over here on our little chart. Try not to show stuff yet, okay? So that we go through it together. All right. Now, we've got the two components. How do we use them to get the resultant velocity? Well, they're both vectors. All right, you've got a horizontal and a vertical one. So to get the hypotenuse, we're going to do what we've always done, Pythagorean theorem. Okay, so if you use the Pythagorean theorem, you should get, there he goes, 72 meters per second. All right, and if you need to pause the video and copy that down, you can. So the final velocity is going to be the square root of the x component squared plus the y component squared. So 70.2 squared plus 14 squared. Take the square root of the sum and you get 72. Sounds pretty reasonable, doesn't it? It's bigger than both of these, as the hypotenuse should be. Now, we need the direction, okay, relative to the ground, relative to the horizontal. Well, that's where we're going to use the inverse tangent. And it's going to be the opposite. Remember, we always measure the angle next to the horizontal or to the ground. So that means the opposite leg to the angle will always be the vertical. The adjacent will always be the horizontal. So 14 over 70.2, you get 11.3 degrees. Now, for the answer to A, part A, the final velocity, and boy, we did a bunch of work to get there, but we did it, 72 meters per second at 11.3 degrees below the horizontal. And don't complain. I had problems when I was in freshman college physics, algebra and trig-based physics like this. They were 2 or 3 pages long. So don't complain because none of mine are going to be like that. All right? There is the final velocity then. Okay? Now, let's take a look at part B. whoops, wait a minute, let me turn it the other way. Is this the right side? Yeah, okay, sorry. Let's take a look at part B. So I'm giving myself some more room here with another sheet of paper. Look what it says right here. Determine the maximum height above the ground that the ball reached. Okay? Oops. All right, part B. So we want to find h, the maximum height above the ground, which is vertical. So that means we need to use vertical information to get it. Oh, I'm sorry. It just dawned on me. I didn't put these in here like I should, did I? Okay, so right here, we need to put 70.2 for the final x component, and for the final y component, it's 14, but remember it points down instead of up, so we need to put the negative on it. I forgot about that. Sorry, guys. All right, so the maximum height. Now, I want to go back up and look at the maximum height reached. There's another piece of information I wrote down a few minutes ago on that piece that got deleted by the computer. All right. At the top, we know that it stops vertically, briefly, but we also know one more thing. That's the fact that because of symmetry, all right, if you take away increments of 9.8 and add back those same increments, then because of this symmetry, the time it takes to get to the top is half the total time, half the hang time. And we can find that. That's easy. Okay? So let's take a look. All right, the time for our ball to get to the top would be 1/2 the total time for the trip, which we know. So it's half of 2.85 seconds, which I believe is 1.425, let's say 1.3. Okay, that'll just make it easier. All right. Oh. What am I doing? That needs to be an equals in there. I'm trying to multiply. I don't know why I'm doing that. Okay. I think the computer freaking me out. Just, ugh. Okay. That's what we'll use. That's the time to get to the top. Now we can use that in the general equation to get the height. Now, we know the general equation says y sub f equals y sub o plus v sub o yt plus 1/2 ay t squared. We also know that we start on the ground. We do have an upward initial velocity of 14 and an acceleration of negative 9.8. We also know that to get to the top, it takes half the total time. So what am I going to put here? That's the height we're looking for. We want to end up, we want that to be our final point for the time we're going to stick in, okay? So we'll put that h in for that. So now we get 14 meters per second times 1.43 seconds, the time it takes to get to that point, plus, and we're going to take away from this because of our deceleration, 1/2 times negative 9.8 meters per second squared and 1.43 seconds squared. All right, so now if we do this, notice the seconds cancel on the first product, and we get 14 times 1.43. Oh, we get 20 meters because the seconds cancel out. All right, now we're going to take away, if I bring that out front, half of 9.8 is always 4.9. That's a nice little shortcut if you'll remember it. Half of 9.8 is 4.9, so you can always just look at that and say 4.9 and then times 1.43 squared. So 4.9 times 1.43 squared. Oh, that gives us, I did it wrong. 4.9 times, I hit the wrong thing, 1.43 squared. There, that's better. Oh, okay, that gives us 10 meters. Double check me on that, but I'm pretty sure that's right. So now if we say 20 minus 10, it goes up 10 meters to get to the top. Okay, now if it hadn't been for the deceleration, it would have gone 20 meters. But because it decelerated, we take away that much for the deceleration, it only goes up 10 meters to the top in that time period. Now, this is not the only way to get the height at the top. There are actually two ways because of the symmetry of our problem. And that's kind of nice because you have a choice. So what is the other way? You need to see it. Even though we've got the answer, you still need to see it, and then it does give you the same answer. So look back up here. There's another piece of information we know about the point at the top. Not only do we know it takes half the total time to get there, we know it stops up there. We know if we think of this as our final point for what we're looking at, we know the final velocity at the top is 0. So that means to get the height, which is a distance, we can use the only other formula we have that has distance and the final velocity in it is the alternate equation. So we can use the fact that the y velocity at the top equals 0. So here's how it would look. Now we know that the alternate equation looks like this. Vf squared minus v sub o squared equals 2a times yf, I should put y's on there, yf minus y sub o, okay, which is your vertical distance. In fact, since that's 0, we're just going to say h for this one, okay? But now right here, we want to go to from the beginning to the top, and at the top, we're stopped, so that just drops out. Isn't that nice? Okay, so now since that drops out, all we have left to find h, we take the 2a and divide it over. So we get h equals negative v sub o y squared. Now understand, the negative is not being squared. It's this. You're taking a square and subtracting another square. So the square comes first before the minus sign, okay? And then we're dividing by 2ay. I forgot to put that on there. All right, so for this particular case, you get negative of 14 meters per second squared over 2 times negative 9.8 meters per second squared. You see what happens now? Boom, boom. Those negatives cancel out, don't they? So now you get 14 squared over 19.6. And if you do that, guess what you get? 10 meters right on the nose. So you get the same answer. So there's 2 ways to get the height at the top. You can either use half the total time in the general equation, or you can use the fact that you stop at the top. Starting from your initial velocity, decelerating to a stop, it tells you how far up you've gone. Kind of cool, huh? So there's 2 ways to do it. Your choice as to which way you want to do it. I have no preference, okay? As long as you're careful and do it properly, either way works. Now, last item. Boom. Let's take a look at part C. Oh, yes, I know, this is a big problem, but I'm showing you a lot of different stuff here. It's stuff that's important that you understand. Okay, so part C. It says determine at what times was the ball halfway between the maximum height and the ground? Well, look right here. At the maximum height, halfway between there and the ground, we were right here. Oh, halfway, we were right here. Yeah, it'd be more like right there, wouldn't it? Okay, so about right there. And over here on this side, it would be about right there. Okay, vertically, it's halfway. So there's 2 places where you're halfway between the top and the ground. 2 places, that means there's 2 times. There's a time between 0 seconds and 1.43 seconds, and there's a time between 1.43 seconds and 2.85 seconds. We want to find both those times. How are we going to do that? Well, it's really not that tough, guys. Watch this. Although you may not be very happy with me, but watch it anyway. Okay, so here's what we want. We know that the ball, we want to, well, what is halfway between the ground and the top? We just found the maximum height to the top is 10 meters. So we want to look at a 5-meter position, don't we? Right? That's halfway from 0 to 10 meters. So at what times was it 5 meters above the ground? How are we going to do that? Well, look, Watch this. YF equals Y sub O plus V sub O YT plus 1/2 AY T squared. Now we know that drops out to 0. And this time we want this to be H for 5 meters. Okay, and we've got V sub OY T plus 1/2 AY T squared. Now you may be thinking, well, Miss Pepitone, why do we have to do this? If the distance is halfway to the top, wouldn't you just simply have to take 1.43 and split it in half? And then half that time would be 5 meters here, and add a half to this, okay? And you get it over here. No, guys. No, that won't work. And you know why? Because of this right here. The height depends on the square of the time, not the linear time. This is linear, but this is parabolic. And guess what? When you have a squared term, that takes control over this, okay? So this wins out over that. And you can't get rid of it because you have an acceleration. So because of that, we can't just say, oh, take half the time to get to the top, and you can't do that. It won't work because it's not a linear relationship. So you have to calculate it. And look, I want you to look at this equation we just wrote that we just modified for our vertical side. Look at that. I want you to look. What would happen if I took this over here? Uh-oh. Okay, watch. We would get, and I'm going to rearrange it just a little, we would get 0 equals 1/2 A T squared plus V sub OYT, right? That's those two. I've just rearranged them, minus H. Yikes. Do you all see what I see? Do you? Look what I see. I see 0 equals AX squared plus BX plus C. A quadratic. Now, if we put the numbers in, there is a possibility we could factor it into 2 binomials. So we get 1/2 times negative 9.8 is negative 4.9 T squared. And this is 14. And this is negative 5 or minus 5. Oh dear. Oh dear, oh dear, oh dear, oh dear. Look at that. That is not factorable, is it? So guess what you have to use if you can't factor into 2 binomials? Oh, we have to use the quadratic equation. Do you all remember that? Let's write it together. Do y'all remember how it goes? It goes negative b, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, which in this case, our a value would be negative 4.9, our b value would be 14, and our c value would be negative 5. Okay? So here's what I want you guys to do. Because there's a plus or minus right here, we have to say negative b plus all this and divide by this. And we have to say negative b minus all this, divide by this. That's going to give you 2 answers. Well, it should. We've got 2 different times we're looking for, 2 different points in time where the object is 5 meters above the ground. Guess what? This will get both of them for us. So what I want you to do, and you need to try this yourself on the calculator and make sure you can do the math right. Stick each of these in here and do it once adding and do it once subtracting and see what you get. Now I'm going to do my magic and make the 2 answers appear right down here. T1, the time between 0 and 1.43 seconds, and T2, the time between 1.43 seconds and 2.85 seconds, okay? So I'm going to do my magic trick and make them appear, but you guys need to do it yourself too and double check that you can get them, all right? Bam! Look at that. When the ball is at a height of 5 meters, it could be at a point in time that's 0.42 seconds on the way up or 2.44 seconds on the way down. Pretty cool. All right? Now, you needed to see this. I very seldom give anything like this, but you did need to see what happens, and it also helps you to understand how the height and the time, the vertical height and the time, do have a parabolic relationship, okay? So, now then, I hope that you've gotten all this. Yes, I know it's been a lot, but I told you the full symmetrical parabolas, they're kind of involved. There's a lot to it because you have two motions and it has to go up before it comes down. So that does make it a little more involved than the half parabolas, but that doesn't mean it's not impossible to work. You just maybe have to put a little more effort into it or a little more time. All right, so we'll be working on this the next few days, and see you later. Bye-bye.